Start now. Okay, hello everybody. Thank you for joining our May session of DecisionCAMP. Today we have Seth Meldon from Progress Software, and Seth will talk about rules compression and other related issues, and he will describe himself what they actually did. But everything started with DM community challenge related to benchmarking pretty large decision tables. And this large decision table has more than 16,000 rules, and we ask different vendors to provide their solutions, how fast they can handle large tables. And it was quite interesting results by itself. But what put Progress Corticon in a separate area, that they, instead of handling all 16,000 rules, they preliminary ran their rules compressor, and they managed to essentially almost 10 times to minimize the size of this table by removing duplicated rules or unnecessary rules. And so today, Seth will tell us about these facilities, and maybe it will bring, in general, more interesting discussion about handling big tables and rules compression. Seth, please take over and introduce yourself and a little bit Corticon.
Sounds good. Thank you very much, Jacob. As Jacob mentioned, my name is Seth Meldon. I'm a sales engineer here at Progress, focused specifically on Corticon. And I submitted that submission for the Decision Management Community Challenge back a couple months ago. Learned a bit about the compression in the background as well, because it was when we initially looked at the challenge, we didn't think it was a natural candidate to have a lot of those rules be compressed. But as Jacob mentioned, there was a pretty impressive degree of compression that we could accomplish using just the Corticon rule modeling environment. So what I'm going to run through is largely stepping through the different components of rule modeling in Corticon as they relate to this specific challenge. And I'm going to highlight the rule compression aspect, as in addition to a few of the other capabilities that we went into just optimizing the rules as far as it's the underlying logic when we implemented it. I like this cartoon on the right here to think about the different ways that how much we can document from the way that the rules were initially portrayed within just a giant CSV file into something that is much more readable, and so we don't have a mere miracle in the middle, but have a good understanding for the test cases that we'll see for why a given rule executed and when. And I'm going to be doing all of this with the JavaScript flavor of Corticon that we call Corticon JS. I'll talk a little bit about the components of Corticon JS, as well as the output, which was ultimately a Lambda function, and the Postman collection that you can retrieve from the DM community website and actually test this locally as well for yourself. So with Corticon, just to get an idea of the aspects of how we delineate the implementation of business rule projects, essentially we're going to handle all of those initial stages within this rule modeling environment called Corticon Studio. And so everything from the initial design phase all the way through to the various testing and optimization of the rules, including compression, is what we do within Corticon Studio prior to compiling and generating a JavaScript bundle from those rules directly from Studio and outputting a zip file that we can upload right into AWS Lambda. So just to give a recap of the challenge itself, this was the gist of it. Essentially, we had a Excel table with a bit over 16,000 rules. And you can think of each of these first four as just four of the first 16,000, where Some of the values within those columns there were going to be passed in. Some of those values were going to be produced when those conditions are met. Specifically, just to talk about the inputs and outputs, actually, I'll present that in a moment, but suffice to say, we have about 16,000 columns here, and we want to make it easier to maintain for the business user, the person who actually has the underlying knowledge to maintain the rules, as opposed to really getting those droopy eyes working within that giant Excel table. So how do we do it within Corticon JS Studio? Now, one thing that we started with was this set of JSON tests, and it's a good place to start as far as getting an idea of how we get from this sort of model of an Excel table to an actual runnable decision service. So starting with this JSON payload that is going to serve as the basis for the data model that we're going to build within Corticon, what we're going to do, or what was done within Corticon Studio, was to take that JSON file and populate what we call the Corticon vocabulary into directly into Corticon Studio. So we're essentially abstracting the different data points that are relevant for this use case into this data model. There's only one top-level entity. It didn't have a name here, so I decided to call it encounter. But all the different values that are going to be relevant for the rules are going to be encapsulated within this rule vocabulary. So everything that is passed in, everything that is passed back from the calling application. And we can generate this from a JSON file, from a external database, or from a REST endpoint. But in this case, with that JSON file that we were starting with, we generated just this simple rule vocabulary that you see on the right. And then just in terms of how the actual rules are going to behave, everything in the blue here, this is directly from the challenge site itself. Everything in the blue is going to be the various different inputs, and you can think of those, as it says, as the conditions. Using a slightly different terminology in Corticon, instead of conclusions, we're just going to call those actions. So when specific conditions are met within all of these blue values, then we're going to take some number of actions within Corticon Studio. So in the Corticon rule sheet, this is where we really get the pedal to the metal as far as implementing the rules in this design interface. So here we have the rule vocabulary once again. And as I mentioned, we have the various conditions that are being played out here and the actions. Now, just to acquaint you with the way that the way to look through this sort of decision table here is each column is going to serve as its own discrete rule. And so similarly to that giant Excel table, all we really did was paste the values that were applicable for the inputs, those various different conditions, and the actions that were taken when those inputs, when those conditions were met. So that, again, would extend over 16,000 columns all the way to the right here, which was taxing as far as trying to look at the different ways that we can really understand what the rules are doing, other than just the pasting the values in there. So we made it a bit more maintainable by doing a few different things. So here we just paste the values again, but to clarify just a bit as far as what the rule sheet logic is, what this actual rule sheet design interface defines here is we define the conditions, and when the values specified within these conditions are met, then we're going to take the actions upon these different variables here. So covered in full, copay, and coinsurance are going to be the final outputs. To make it a little bit easier to look at and understand, I put into a different rule sheet the specific date coverage or start date of coverage and end date of coverage into a different rule sheet, just to make it a bit easier to maintain, since there wasn't too much variability within those values. Now, when these rules execute, it's not going to merely send back to a calling application from the decision service. It's not going to only send these actions that were produced. In our case, what we did was also define what we call rule statements here. So when a given rule fires, and only when that specific rule fires, we're going to send back the applicable rule statement, which is essentially going to be just informal language that enables you to articulate the rule quickly, and also documents the rule as part of the output message. So only the rules that fire will have this rule statement. And what you'll see here is for all of the 1 through 16,000 plus rules that we've implemented within this one rule sheet, I have these dynamic variables here in curly braces for encounter plan, encounter place. And as you might expect, at runtime and also within the testing phase here within Corticon Studio, those values will be filled out so that we'll have a more complete documentation of each rule that fires. So if rule number 1 fires, it'll be under the PL123 plan for the inpatient encounters and so on. Now, one thing that we didn't really get into with this implementation, just because it was so, I guess, procedural in the way that those rules have very specific if this then that sort of conditions, as opposed to any real calculations being performed. We didn't really get into any of the rule operators just to parameterize the different conditions and actions and perform calculations upon them. But just to give you an idea of had there been a bit more underlying logic besides just the giant decision table, these are the sorts of operations that we can perform upon the data, depending on the type of data that we define for the various different values in the rule vocabulary. So let's get into the especially interesting part in the case of this use case. And just to talk about the different ways to handle analyzing and testing the rules. Obviously, analyzing each individual rule is pretty straightforward, especially when it is all of these static values, those 7 inputs. When those conditions are met, we're going to take these 3 actions, send back these 3 values. So that's straightforward, but obviously in a more common scenario, a decision will have dozens or hundreds of rules, and the way that they interact can be pretty complex. So there's some straightforward ways to just analyze the logic as far as just things like scenario testing. So defining inputs and verifying that our expected outputs are actually being produced when those conditions are met. So within Corticon Studio, we have a different interface called the rule test. Rule test, simply put, is where we're going to take, again, this same rule vocabulary, define some sample inputs for it, and optionally we can, as in this case, we have an idea of what the expected values should be. So when we run the rule test, we can verify, perform some regression testing to make sure that the actual outputs are in line with the expected values. An idea of the actual, how this is working in the background. Now here is just a expedited sort of run through of me filling out the inputs here. And what this is doing is essentially mirroring the behavior of this decision service as it will behave at runtime. So it generates that within just a local decision service inside of Corticon Studio for this test capability. All it's doing is running the rules and essentially simulating the behavior as it would behave at runtime. And you'll notice back down in our rule messages, we have the more fully filled out rule statements as we had defined with those curly braces, which have now been filled out with more complete messages based upon the actual values that were used in those inputs. So what I had done in that recording was populating out each and every test just manually. So luckily for this challenge, we had a JSON file. And so what we can do instead is to just import from the actual JSON file the various different input JSON parameters and run the test based off of that. And we'll see similar sorts of results here. That JSON file had 10 different test cases as opposed to just the one test case that you saw in the previous example. which is the reason for the much greater quantity of rule messages that have been sent back here. Now, continuing on to the different ways that we can analyze and improve the logic underlying these rules. The way that we think about outside of just using test data, analysis and optimization more so is examining and correcting or improving the logical construction of the rules independent of any of the data that just the simple unit testing using sample data. So with just simple data testing or regression testing by passing in some of those sample data, it doesn't really do anything to inform the rule modeler about the execution efficiency of the rule sheets. Are these really implemented in the most effective way they can be? So what we're going to do is optimize the rules to ensure they execute most efficiently, which will ultimately, when we get to production, ensure the best performance when we actually generate the decision service. So first up, the compression that we're running the rules through here is basically designed to reduce the results set across all of these different actions into a much more manageable number, while simultaneously ensuring that we're not introducing any new ambiguities into the rule sheet. So by compressing the rules here, you'll see, obviously, we've gotten to just about 1/16 of the rules that we initially had. And you'll notice that what Corticon did here was add in combinations of values where we see there was the same action being taken for different scenarios where, say, PL012 and office and organ donation, that was its own discrete rule. And Corticon picked up on the fact that we can just combine these rules and we will have the same results, thereby reducing this massive number of columns of rules to make it a bit easier to manage and understand, as well as perform at runtime. Now, we're not done with the different ways that we can handle just the analysis of the underlying logic of the rules. We have some different ones that honestly are more commonly used, and it's not as common for us to see such a massive decrease in the quantity of rules necessary through that rule compression tool. Some of the other ones that are there are things like the conflict checker, where we're going to check if there are any conflicting rules. So the rule writer ideally is going to be someone who knows the business problem. And so when we identify conflicts, as we're doing here, which is essentially saying for the same, more or less the same exact set of inputs, we're noticing that slightly different actions are being performed. So there's a specific set of inputs that have the coinsurance output being Y and a certain combination that have it being N, even though it is the same inputs. So by presenting this to the person who has the actual underlying business knowledge, and I think what I do here is just to demonstrate the specific combination of values that Corticon is picking up on having overlap. So the rule modeler can now focus instead on either changing the actions here, making it perhaps there is a problem, and for this set of sample values, there shouldn't be any differing output. It should be all no, 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 or yes, 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 or no, no, yes. Or we can use an override. So I didn't run through any of these optimizations as far as populating out more rules to be more specific here. But one other way that we can address this is to just say within this override row here, in the case when these two are at odds with each other, when there is a conflict with one another, just think of an override as an exception. We'll override one rule with another, and this will instruct Corticon at runtime to fire only one rule, even when both of those conditions are both satisfied. Now, the next one that we can run through is completeness. So this is...
Seth, can I interrupt you for a second? Can you go back to previous slide? Yes. When override done by business person who understands the logic when there is a conflict between two rules. And business person can say rule 25 overrides rule 15. And how you will save this information about override? It would be saved in rules themselves for future executions?
Yes, so within the actual interface, we would just put in, say, if rules 1 and 2 here are in conflict with one another, or within this specific example where these two are actually in conflict with one another. Right here, if I want this to be the value that it supersedes the other, then I would just say right here within this cell 25, in the case when they are at odds with each other, I want this rule to override rule number 25 and have the output of rule 25.
But this action, override action, would be somehow saved for that other people would know about this override? Or this is one-time action? Will you save it back to your representation of rule?
Yeah, so this would be carried through. So this is just the local rule sheet itself, but that logic would be incorporated into the decision service at runtime. So it's no different than the way that we can document these conditions and actions directly within the rules. It's going to be retained within the rule logic later on.
Okay, let's keep going.
Now, this next one is checking for completeness, which is actually going to add a few more rules. And this kind of brings up some interesting topics as far as by compressing the rules, we decrease the number. And then here you'll see, obviously, there were specific combinations of values that did not have any action defined for it. Corticon does not like to live in the world where there is any ambiguity here. And what you'll notice is while it built these new conditions for us, and so the rule modeler just has to define the actual action to take given these conditions, it also did its own degree of compression by combining if its group size is not L, or it is not null, or it is null. And it's doing that based off the fact that there are all of these different potential permutations of the rules, while also handling that compression so that it's not having one individual input per one of these condition cells. And so when we actually do this completeness check, the algorithm's not only identifying the missing rules, but it also compresses them into what we call non-overlapping columns. And so the compression performed by the completeness checker is a different kind of compression from the one performed by just that compression tool. The optimized columns that are produced by this completeness check contain no redundant subrules. So that's what we mean by non-overlapping. Whereas the compression tool from the previous slides will intentionally inject redundant subrules in order to create these dashes here wherever possible. So it makes it a bit easier visually to represent the rules while reducing the actual quantity of them. I know the title and the inspiration for this session was on compression, so talked a little bit more about compression here just to talk through what Corticon is doing within that compression step. So to distinguish between the compression that's happening between those two different tools a bit further, the real value in doing so is that the compression tool itself is preserving or reproducing the main patterns that are meaningful to the actual rule modeler. And the compression tool, by reducing a rule sheet to the smallest number of columns, makes it far more, it makes the code itself that's going to be produced by Corticon Studio when this gets compiled into a decision service, makes it a higher degree of performance. And also, well, essentially because Corticon does not have to analyze that many more sets of conditions that are being defined at runtime. Last one, which luckily we didn't have, so we didn't have much of a result from this specific check, but we can check for logical loops, which are sometimes inadvertently created during rule implementation. So cases where we're defining some action and there's some mutual dependencies that we need to identify so that there's not an endless loop taking place within the execution of the rules. So we don't have that problem. Now, those are the key areas of testing and optimizing the rules. And just to run through how we get this into the live service itself as a Lambda function, all we're going to do is take that initial rule sheet, and I mentioned how I separated out the date validations into a separate rule sheet. And the final step within Corticon Studio is to define basically the chronology of the rules as they're going to be run through at runtime in what's called this rule flow. So this rule flow is the final step, and this is essentially from the rule flow, we're going to generate a Lambda function directly from the rules underlying each of these rule sheets and organized into this rule flow. So on that rule flow, we can essentially right-click and take a look at this wizard for our target platform for the JavaScript bundle that we're looking to actually run. For this case, we selected AWS Lambda. There's the other cloud platforms there, as well as Node for running it within a mobile application or to run it directly within a browser with the browser option. Now, what that will output for the Lambda option is the specific files that Lambda would be generating had we coded this originally in JavaScript and uploaded it into a AWS Lambda function. So here I just create a Lambda function. I'm going to name it the Decision Management Community for February. And from there, let's just import what was exported as that decision service file. Here I just upload the zip file, and you'll see it's going to behave. It's going to be auto-populated throughout this Lambda function. So Lambda will, or AWS will know what to put where. And so we have this decision service bundle as well as that index that has been organized for us. And now we can perform some testing on this actual Lambda function itself once we go ahead and deploy it. So in order to access the Lambda function, we need to add a API gateway so that we have some sort of trigger actually handling the invocation of this decision service on AWS Lambda. So for the purposes of this challenge, I just created a basic open URL to call this specific decision service through that API endpoint. And then I'm going to run this through Postman just to give an idea of what the actual behavior will look like when we test it outside of just the rule tester. But what I can do is take that initial input that I had, export that JSON, and if you recall, it was the same sort of workflow of in the rule test, it was replicating the behavior at runtime. So that's why we have this easy to understand JSON. It's the same JSON that's happening within the rule test itself. I'm just sending it to get a representative sample of the speed itself of the actual decision service. And here we're seeing the outputs as we expect them, and the timestamps along with these rule statements. So those rule statements were an added component from the payload that we incorporated. And essentially, we just added that to make it more understandable what rules had led to what output. But in the submission itself, we removed these rule statements just to get peak performance from the decision service on Lambda. So if you do want to replicate it on your end, that's why you won't see the actual rule statements be sent back. All right, so that's kind of the soup to nuts of this implementation. And I know I kind of went through a lot here, but I'm definitely happy to take any questions now.
If you click several times to send button on Postman, it will probably will increase speed, right?
Yeah, well, after the, it's only the delay, it's only delayed after when it's first
Yes.
invoking it, but number 2 and number 3, it's what we found with Lambda is it's pretty much between 15 and 25 milliseconds per execution after that initial invocation.
Okay, great presentation, right to the point, and we do have, I'm sure, questions, and already question from Bob Moore. Bob, you can say this, or you can read it. Says on the
in
on Slack.
Yeah.
Yeah, no, I've read that. I mean, I've been playing around trying to do my own sort of solution to the challenge, um, and I sort of had some issues with the CVS file, because basically I was trying to kind of directly import it, and it has some interesting little quirks in it. But I was kind of puzzled by the fact that there do sort of seem to be conflicting rules within there. So you know, you have identical conditions and different outcomes. But if it's basically intended that you effectively you either take the first version or the last version. That was the second question, but I mean, it's something which, if you kind of just directly import the data, you're potentially going to come up with the wrong answers because you don't know. And this goes back to the challenge we had last year about how do we actually compress decision tables, and that if we go through a compression process without actually understanding what the business logic is, you know, why does the business have this table and what do they want to do with it, then we can actually make errors because we're actually doing the compression in the wrong way, which is one of the things I think that perhaps is something which we do need, you know, we do need to consider, because I mean, Seth has shown us that you can do some automatic work on doing the compression, but that's undirected, and that's just sort of looking at the data, whereas that might actually not be the appropriate thing for the business to do. Yes, they want to compress it, but the way that the automated tool does it may not actually be best for the business purposes.
Yeah, that's a great point. I think the fact that we can identify the fact that, well, the different issues with the logic here all within the same screen and testing directly against the rules as we are handed the specification for the rules makes it that much more likely, hopefully, that the person that can say what should override what is going to be the one making that decision.
Yeah, but I mean, the question I would ask when looking at this is saying, well, you've got these 16,000 rules, but I mean, why have you got different rules for different policies? What are the differences between policy 123 and policy 124? And how do you going forwards, how do you actually want to kind of maintain your different sorts of policies? Because that then has very radically different effects on the way that you would try and optimize the way that information is represented when you're moving away from an SQL table to decision table. And I mean, my guess would be, well, we don't want one decision table. We want several decision tables, which allow us to focus on what our business objectives are in a more refined manner. But that's taking the challenge off in a completely different direction.
Yeah, I mean, to your point, that even this post running through all of these optimizations is very far from what we'd recommend as best practices if you're starting from scratch. Just in terms of the number of, let's say, for example, within this table here, these are all static values that we're defining, literally a string of text for inpatient, of office, whereas we could have had a degree of abstraction here by actually having the references to just this, say, encounter.plan and have that be actually static somewhere else. And we're only defining this as a variable versus in this gigantic table, it's still over 1,000 records here, and having to have this manual typing out of each of these different combinations. Definitely not the easiest way to accomplish it, and certainly not the easiest way to maintain it longer term.
Any more questions? Says, I want to continue the question what Bob asked. Actually, he asked if rules down in table can override rules at the beginning of tables. And so it's unavoidably brings us to the question about single hit and multi-hit decision tables. And my direct question to you, is your table, what you implemented, single hit after compression?
I'm going to bring in Jim to speak a bit more to that. And I don't know if Jim, you're able to speak now. Looks like you're off mute, but.
Sorry, Seth, I had my microphone flipped up. So the question, are we single hit or multi-hit decision table?
Yeah.
So with Corticon, you're not, when you're defining your decision table, when you're defining your rule sheet, you're not defining an order of execution. Rules will execute until there's no more execution to be done. The inferencing will be done, what rules should execute. So it's not, from a single hit, it's not like there's only one rule will execute the table. Multiple rules can execute, and the execution of one rule can cause another rule to trigger and to execute. So from that perspective, I think from your definition, that would be a multi-hit decision table.
It's a little bit more complex. Usually rules execution does not cause the execution of other rules in multi-hit tables. If you look at DMN, for example, specification is prohibited. Yeah. But so your answer is that it's multi-hit. Okay.
Yeah, I mean, the rules themselves don't trigger another rule to fire. It's because they're updating the data model.
I think the question is more if you have two rules where the input conditions both match against them, then you've only got one slot to put an output in. So you're going to get the output from one of those two rules as your result fed back. I mean, in this specific case. So the question would be, is it the first rule reading from the top that gets written out? Is it the last rule that's from the top that's written out, or is it randomly chosen between some of the sets of the rules where all of the conditions match? Because the business, because they've set things up like this, have a specific expectation, which is effective their overriding mechanism, and I mean, from a practical perspective, this is information which we didn't have when we started looking at the problem. So if we come up with a wrong answer in terms of what the business expected, that's not really a problem. That's just really a matter of rephrasing it so we can do it. But I think that, I mean, my expectation from a multi-hit decision table is that I get back all of the answers. So I wouldn't get back a single field. I would get back, these are the possible values for that field, or these are the possible sets of values that I could get for this input. So it's not a kind of multi-hit is I mean, I wouldn't regard this as multi-hit even from what Jacob has said, because it's more like, is it the first one that fires, or is it the last one that fires, or is it some random one chosen according to some scheme you don't know?
So if you have multiple rules and they all equally match the criteria, they all could equally fire, it's effectively random. Now there is a logic as to what would fire, but it's not logic that's relevant to the user. They are effectively random, which is why Corticon gives you the tools to find your conflicts. And as Seth was showing, you can do the overrides and say, well, I want this one to take precedence. So that's what basically gives you that the user control over those conflicts. So the multiple rules could fire, but from your standpoint, you're not getting back the full range of answers. You're getting or matches. You're getting back the single match that was done.
No, I would be inclined to shoot the person who came up with this scheme anyway. But I mean, I'm a strong supporter of first hit decision tables, but I am not a supporter of decision tables where you have a random scheme for overriding things. It's just nutty.
Yep.
So just because I'm unfamiliar with the terminology, by multi-hit, you just mean presenting back all potential values.
That's what the DMN specification says, as far as I remember when I last read it.
It depends how you can define. That's not exactly DMN does not dictate this. DMN allows you to define different types of hit policies, but your answer. This is in your conclusions columns, you can put not single variable, but array of variables, and you can accumulate in this array all possible answers, as Bob suggested. And then you can write another table that will take this list of produced results, and it also knows which rules produce them, and it can compare them, and explicitly overriding logic could be expressed in another decision table. That's one of possible way. But I would tell you that because I know the origin of this decision table in real world applications that in production for many, many years, and that went from several hundreds to thousands rules created by business people, and they're not always the same people, but what they really worry about overriding logic was that rules down in the table override rules on top, and it creates almost macaroni relationships that impossible to maintain, and splitting this logic is extremely difficult. And so I would say that I really happy what you guys you brought this discussion about rules conflicts, because we started with compression, but it unavoidably brings us to rules conflicts. And this is in real world one of the most difficult topic when people create after being in production for many years. It's conflicts are unavoidable. So how to deal with conflicts? Probably we will have another special session about conflicts. And I would actually ask everybody if you have something to contribute to this topic, and apparently Corticon has their own very interesting tools. So just bring this to DecisionCAMP or to another session, and we will discuss this. I want to bring other attendees. Do you have more questions? Anybody? Okay. So in this case, I want to thank you very much for interesting presentation, and Corticon certainly has a very, I would say, unorthodox approach to these things. And before we go, I want to ask one more question. Did I understand you correctly? You do compression during compilation when you create service, or you compress and keep these compressed rules?
It's done at compilation time.
In compilation time. So you always deal with the original table, not with modified rules.
Correct.
I
mean, your rules can be parameterized. You know, the value for any cell in the rule sheet can be parameterized, but Corticon will do its best to compress things based on the data that has available at the time that you're authoring the rules.
So you're not offering results of compression to your business people. They still deal with original table before compression.
As part of authoring when you're writing your rules, you can compress rules. If the rules are effectively identical, they can compress down to a single rule. Then that's effectively in the assets at that time. So I'm going to see if I'm interpreting the question correctly. From the user perspective,
I think the question is, when we're looking at the screen and we see things like effectively, if the plan is, you know, PL 0112 and the encounter place could be the office, it could be outpatients, it could be inpatients, is the sort of rule that the business is seeing, or are they still seeing 16,000 rows?
They would be seeing a single rule.
Yeah. So I think what Jacob is asking is basically are the business seeing the compressed rules when they look at the rule sheets? So you know, the compression is effectively something which is
like on this screen what they display.
Yeah.
This is a regional table, and this table is equivalent to this compressed table. So after your compression, do you give business people this table, compressed table, on the right?
They would be working with the compressed table, yes.
Okay, hopefully this is an option. Okay, in general, I would invite everybody after this discussion to look on this challenge in September 2020. There are several solutions on this, and one of them, or a few of them, related to application of machine learning for compression. Maybe you guys in Corticon also could be interested in this approach, or you're very welcome to supply your solution to this challenge as well. Okay, our time is up, and I really want to thank you very much, Corticon developers. And if you have people and all attendees have more questions, you always can post them on this forum, monthly session, and I'm sure Corticon specialists will answer your questions. Thank you very much, and see you in a month.
Thank you.
Bye.
Thanks very much, Seth.